The next topic is linear regression, section 3.3. This topic is closely related to the latter part of this course, inferential statistics, in a sense that we have to do some prediction and estimation. Basically, what we want is this. In a scatter diagram, we try to find out something called a regression line. Roughly speaking, it's going to be a line of best fit. And given x value, if you know the equation of the regression line, we can find out the y value by simply plugging in x value into that equation of the line. And that way you're going to get a y-coordinate value right on this black line, either in figure 3.17 or 3.18, and that's going to be the best point prediction or the expected value. What am I talking about? Let's explore it through a concrete example. By the way, here is the formula that you have to remember, the regression line formula. Y equals to R sy over sx, parenthesis open, x minus x bar, parenthesis close, plus y bar. X bar is the mean x value. For example, if you have midterm exam score and final exam score, then x bar is going to be the class average of midterm exam. Y bar will be class average of the final exam score. We know those scores. Alright? What is Sx? That's the standard deviation of x, so standard deviation of the midterm exam score. And in the numerator, Sy, that's going to be the standard deviation of the final exam score. And finally, R, let me try to, okay. Finally, R is a correlation coefficient. All these are known values, or from the data we can calculate given time. The only unknown, x and y values. So plug in x values can be anything, 70, and then run this computation, and then you're going to get the y value. That's the regression prediction. Let's do that for a concrete problem right here. Let me use the same data set that we went through before. We use the same data sets to practice calculating correlation coefficient using Excel file, and then I brought those files back here. X bar, which is midterm exam score, the class average of the midterm exam score is 56 point something, and Y bar, the class average of the final exam score is 52.55 something. Standard deviation of midterm 18.56 something. Standard deviation of y, Sy, is 27.43 something. And finally, correlation coefficient R is 0.38 something. We calculated all these before in the previous video. Okay, in this section, we're going to use those. How exactly are we going to use it? Well, right on the top, we have a formula here, and this is what we're going to use. And let's go back down here, and then let's copy that so that we can use. Alright, find the best point prediction of the final exam score of a student if the student scored 58 points in a midterm exam. What do I mean by that? Well, here's the formula, and we want to find out the situation where students scored 58. Run this computation, and this y value is something we have to find out. Okay, how do I find out? Well, what is my x bar? 56 point something. That's gonna be my x bar. All right, that is, okay, sorry. A little bit of copying mistake. Alright, how about y bar? Let's go to the Excel file again, and here, this is the final exam score, the class average of the final exam score. Alright, how about Sx, the standard deviation? Let's go to that Excel file. Standard deviation of midterm exam scores, 18 point something. Parenthesis open, and let's find out correlation coefficient 0.38 something. And to save some time, I'm using my mouse to copy and paste. And SY, finally, this is going to be standard deviation of Y. Copy and paste. And we have this kind of computation. So Y value we are looking for is based upon this computation. Even with candidate calculator, with appropriate cutoff of some appropriate cutoff, we can calculate this thing. I want to save some time, so let me just use mathematical computation to do that. And this is what we got, approximately speaking. 53 point something. So if the student scored 58 points in the midterm, the best point prediction or the expected value is about 53.37. That doesn't, of course, mean the student will score this point. After all, as you can see, we have scatter diagram. Those dots are all scattered around. So this is going to be the expected value. Give or take, we're going to get something. Now, exactly what do you mean by those give or take? And what is the error? How do you estimate? That's going to be discussed in the latter half of this course in inferential statistics. At this moment, we are only doing regression prediction. And the formula for regression prediction is right here. Well, we have plenty of time left, so let's do another problem. Similar problem. Let's create another, oops. Okay. Find the best point prediction of the final exam score if the student scored not 58, something like 75 points in the midterm. How do you calculate that? It's going to be the exactly same formula, except that x value is going to be 75. So you can use your handed calculator with the same thing, very same thing. I'm using Mathematica, so I can do it far more efficiently. So this is what we want. Just change this thing, this 58 by 75, and then run the program. And then, oh, wait a minute. Okay, that's it. 62.97 something. This is what you're going to get. This is going to be the best point prediction if the student scores 75 in the midterm. You see, it's the same formula, same computation, same numbers, just plugging in differently. Okay, getting warmer. Let's do it the other way around then. Find best point prediction of the midterm exam score if the student scored 75% in the final. No, excuse me. Let's do it this way. 62.97 points in the final, or let's use 63 in the final. So what do you get? We started from 75 and we ended up getting 62.9, so approximately 63. So let's go backward. Let's start from final exam score of 63 and then run this regression prediction. Am I going to get 75 back? Actually, no, we're not going to get 75 back. We're going to get something different. We have different formula here. As a matter of fact, I'm glad that I'm doing this exercise because I just found out a typo here. Okay, of course, by the time you're working out this notebook, everything must have been corrected, but I just corrected a typo here. Here's a second formula. If you're looking for x value for given y value, we have very similar formula here. And instead of x, we use y. So basically, we are just exchanging all x's and y's. And our regression coefficient stays upstairs. And that makes a significant difference. So here we go. This is a formula we'll have to use. And consequently, let's see, what is x bar? This is x bar, the average midterm exam score, and this is y bar, average final exam score. And then let's see, this is sx, isn't it? Sx. So that goes to numerator. And this is R, correlation coefficient. That goes to numerator. And then this 27 point something, that's sy, that goes to denominator. And this is a computation you'll have to run. Oh, wait a minute, I forgot. Student score 63 points, so okay, 63 points. Plug in y equals to 63, and then run this. You can use handheld calculator, but I'm using Mathematica here. So I got a little bit quicker computation, and the computational detail is left to the students. You can use calculator for that. It'll take a little bit longer, but you're gonna get the same value in the end. 59 point something. So even though we started from 75, it got into 63 by doing the regression prediction. And if you start from 63 back again from the final, and then what we get? We got 59. So we started from 75, and then we got down to 59. And this is the reason the name so-called regression came into play. And looks like each time we do some prediction, looks like we are regressing. As a matter of fact, we are regressing toward the average. If we start from really low score and then do this regression prediction twice and come back, and you're going to get much higher score that is getting pretty closer to the average value, because you see average final exam score, average midterm exam score, excuse me, was 56 point something. We started from 75, and then we got down to 59 point something, much closer to the class average of the midterm. We have a little bit of time, so let's do this again. All right, let's do another regression prediction. Okay, this time, find the best point prediction of the final exam score if the student scored, let's say, 59 points. Okay, 63 points, we got up to 59, and from 59, am I gonna get something close to 63 back? Well, by this time you would have understood why. No, we won't. We're gonna have a regression. We're gonna get a value that is gonna be much closer to the average, which is 52 point something something. So we started from 63, 59, all right. X value is now 59. And then we have to put in all those x values. As a matter of fact, I think I can recycle all this computation here, except x equals 58. This is 59, okay. And then that's approximately equal to something. Let's calculate it. Instead of using handheld calculator, which will take me a lot, I'm using Mathematica to do that, so I got a lot quicker computation here because I can use copying and pasting. In any case, I ended up getting 53.93 something, about 54. I started from 63 this time, and then did regression prediction twice, got into 59, and then we end up with 53. Again, gradually we are approaching back into the average. That's what the regression effect is all about. Each time we do, we get closer and closer and closer to the average. I start from somewhere from x equals something, do it twice, and then new x value, get y value, and then from there get x value again. You're going to get a value closer to the average x bar. The same thing for y. Y equals something, do the prediction, and we get x value. Do another regression prediction, get a new y value. The new y value will be closer to y bar. That's how the regression prediction is working.